Let's talk the talk. Here it is, page 813. Whoa, wait a minute. Where's all the math on this? Complete the graphic organizer located on page 814 to record examples of the types of compound events you have studied. I knew it was there all along. So pause and write, and then we're going to put stuff in this space. So give yourself space to actually write some probability fraction formulas, okay? Assuming you paused, and you're back to unpause, so pause and write down here. And I'm assuming you pause and unpause, and so you're ready to go again. Let's take a look at the first one. And you know what? It really does help that if we're going to talk about flipping two coins and recording the results, we better have some coins to flip and get it in the camera view. Oh, two tails? That's actually the other one. Let's work kind of backwards here because I just popped up tails and tails. It's the back of the, heads. Tails. Okay, so the probability of flipping tails on the first and tails on the second is a formula that looks like this. Probability of tails and tails is the probability of tails times plus the probability of tails, take away the probability of, me and my writing. Okay, I've messed this up. I've goofed it. Typo time. Or, doggone it. Okay, I'm good. So I'm going to answer this one. The probability of getting tails on the first flip or tails on the second flip is probability of tails on the first flip plus probability of tails on the second flip plus the probability of getting tails on both of them. So that would be 1/2 plus 1/2. Take away 1/4. There's a 3/4 chance of that happening. Oh my gosh, I feel like I totally fumbled this and I should go back and start over, but it's too late. The video is already cutting and printing. So let's go. Let's go to the first one, A and, oh my gosh, this is why. There's a typo here. Or there's a typo here. Or someone's gonna hear about that. Okay, maybe your book already has the or and you're saying, what's the brand? It's because I fixed it with the publisher. Okay, independent events, flip it. I even try to flip it heads. Flip it, there it is. And the first coin is heads, and the second one is also heads. The chance of that happening, where it's both, is the probability of heads first and heads second. So probability of heads times probability of heads. 1/2 times 1/2, which is 1/4. This 1/4 is why that's a fourth. So maybe some highlight to make them in common. This 1/4 is that 1/4. Get these coins out of here. Let's talk about cards. Or and probabilities. Choose 2 cards from a deck of 3 kings, 2 queens, and a jack without replacements. So once I take a card away, is this your card? I'm not putting it back in the deck of cards, and now I have 5. Was your card the Queen of Spades? Check that out. Okay, so our question is probably something along the lines of this. Question: what is the probability of choosing a king and then a queen? And is the key thing, right? So we're still talking about king and then queen. So probability of king and queen. Well, our formula for that is probability of king times the probability of a queen given that a king was chosen first. So here's how this would look. Okay? I have 3 kings in the hand out of 6 total cards. So the probability of choosing a king is 3 out of 6. And I'm going to multiply that by, all right, take a king out. Gone. How many queens are left in this hand? 2 out of 5, 2/5. And when you multiply, that multiplication is the probability of getting a king first and a queen second. 6 out of 30, which reduces to 1/5. There's a 20% chance, if you think about fractions as percentages, there's a 20% chance of drawing a king and then drawing a king and then a queen. No, dang it. A king and then a queen. Haha, I win. Let's do the next one. The next one is the same scenario without replacement, drawing cards, and choose 2 cards from a deck of 3 kings and 2 queens and 1 jack. What's the probability of choosing a... There we go. What is the probability that is visible on the screen? Yes. Of choosing a king first or a queen second? Queen second. So it looks something like this. Probability of king first or queen second. So that would be probability of a king plus the probability of a queen. Take away the probability of a king and then a queen. King going first and queen going second, which this one right here is that given conditional probability. So it's probability of a king and the probability of a queen given it was a king. This whole thing right here is a mess, but that's all right. Draw the sample space. I just don't have enough space in my space to draw the sample space. You're with me on that. Okay. Drawing a king first. Well, in this deck, how many kings are possible? 3 of them. Drawing a king first reduces the number of cards in the deck to 5. But the first choice, the probability of drawing a king first, is 3 out of 6. So then now that that card is gone, that king is out of the pile, we have 5 cards left. A king was drawn first. There are 2 queens for 5 cards. Oh, apologies. It's just independent. This is an independent calculation. This one over here is the dependent problem. So hang on. Reset. The probability of drawing a king, 3 out of 6. The probability of drawing a queen, in this hand, 2 out of 6. But we have to take away the probability of drawing a king times the probability of drawing a queen given that a king was drawn. So one of the kings is gone. There's 2 queens out of 5 cards. 2 out of 5. Okay, here we go. 3/6 plus 2/6 minus, this is 3 times 2, which is 6. That reduces a 5th. Oh, I need some help. Where is my phone? Hey, Siri. Hey, Siri, what's 3/6 plus 2/6 subtracted by 1/5? Hey, Siri, what's 3/6 plus 2/6 minus 1/5? Nope.
That would be
Nope. Hey, Siri, what's 1/2 plus 1/3 minus 1/5?
It's approximately 0.6333.
Okay, there it is. Like, comment, and subscribe. Dependent events with OR.